Capitalized Math Industry, and we are going to take a look at empirical formulas. So we've been taking a look at molar masses in our chemistry videos, but empirical formulas are basically another way of expressing the formulas. However, they are more simpler. So what we have right here looks like a compound. The formula is C5H10O5. But there is a little problem. This compound is not in its simplest form. That means it's not in its empirical form. So what we have to do is, right now it's currently in its molar mass form, or it's currently in that form, that molar form. All we have to do is somehow do something to make it easier to understand.
Choose your fighter, Mario!
Many math teachers and science teachers are like, simplify this, simplify that, do this, do that, blah, blah, blah. So that's what we want to do with this, is we got to somehow simplify it. So if I easily divide everything by 5, because everything is a common factor of 5, then that means that I'm going to have C, H2, and O. Done. This is our final answer. It's literally the same thing, but now we don't have to worry about the number of atoms that are present, since it's already simplified down to a much easier answer. So that is what an empirical formula is, simplifying things, and the most simplest form that you can change them in. So if we understand how to simplify that, because we already got the formula and the compound, how are we supposed to solve something that looks like this?
Zero Suit Status!
So somehow we have to get to a formula in its most simplest form. Instead of the problem giving us the exact, molar formula, what we're gonna do is change it somehow. Instead, it's talking about the mass of it by grams. I changed the lighting so it could be easier to see. So, we are given 7.31 grams of nickel and 20.0 grams of bromine. Let's write them onto the side. So we have 7.31 and 20.0. And that is nickel and bromine. So the problem is, we still haven't gotten to that formula, but we took a step closer to it. If we take a look at the molar masses on the periodic table, nickel right here is going to be 58.69. So we're going to change this to the number of moles so we can understand how many moles there are. Because even though moles is not abbreviated for molecules or atoms, it still tells you how much there is in that formula. So 1 mole is going to be equal to, for nickel, is 58.69. Now we gotta do that for the other one. 1 mole, is equal to, for bromine, or boron, bromine. Here's bromine, 79.90. So what I'm gonna do is say 79.90. These are the molar masses, so if I had a mole of nickel, it would weigh 58.69 grams. It would feel like it, and its mass. When we do the answer, we'll get an answer of 0.12 moles, and the other one will be 0.25 moles. So let's build the equation again. So what we have is, for nickel, we have Ni, 0.12, and then we have Br, or bromine, and that is going to be 0.2. What? This does not seem right, because normally when you see the problems or the formulas in chemistry, they're like whole numbers like these. So how did we get with decimals? We did the steps correct, but we forgot to do one thing, one more step. What we have to do is somehow get these numbers into whole numbers. So what we're gonna do is we're gonna use something like a least common factor or the greatest common factor. These two can easily be divisible, but we're gonna use 0.12 because that can easily be the smallest number. So there's no like decimals, because there's no such thing as like half of an atom. You can't do that unless you use like an atom slicer or whatever those machines are called. So 0.12 and 0.12, this and this is going to cancel out. So nickel is going to have one atom. And boron, it's not going to be 100% because off by like 0.111%. We're going to say that's going to be close to 2. So we now have a final answer because now it's just atoms and formulas in its empirical formula. Nickel is 1, bromine is 2. It's basically like nickel dibromine. Yeah, that's the compound. So what's happening in this video is we're taking a compound and simplifying its version so we can easily understand it more. So we don't have to worry about the numbers. And also, how to communicate with your lab partners. Here's what it basically is. It's just like how the Qing dynasty in China formed. It had all these different empires, these tiny states battling for power. Then one of them conquered them and unified them all and became one empire.
Great Wall of China has been built.